So some examples to practice the use of additional substitutions suggested. First, a situation of the form 1 by ax square plus b into root of cx square plus d. One standard method available is x equal to 1 by t, that we have tried already. Now let us try a new substitution, x square plus 3 by x square plus 2 equal to y square. To implement the substitution, I need an equivalent for dx. Let me first make a calculation of that. Half into this to the power minus half into derivative of this dx, or on little bit of simplification, two x cube minus 2x cube cancel, plus 4x minus 6x. Yes. Okay. Root of x square plus 2 also may be removed. Right. And 2 also may be removed. Okay. So this much material is needed with dx to bring in dy. Let me first bring in all these required things so that I can easily think of introducing dy in the expression. So I becomes, first I will write down whatever is needed to bring in dy. Then adjust the other things, which has not been covered fully. X square plus 2 has not been fully covered. One portion still remains to be covered, and that portion is x square plus to the power half. X square plus 2 to the power half. Agreed? Okay. Is it okay? Minus half, or it is x square plus 2 power half to be written in numerator. Okay, let me have that itself. Then of this part, root x square plus 3, surplus has been covered, more has been covered. So to balance we must, sorry. This is the other factor, has been covered exactly. Then next factor which has been covered extra is this minus x. To get rid of that, we have to write a x here. This is root of x square by x square plus 2. Then the other things remain as they are till we get a replacement for x. Now, how to get this obtained in terms of y? That is the question now. Our expression for y square is this. We are required to find a suitable replacement for this. We have the denominator as desired, x square plus 2. But in numerator, you do not have x square plus 3, you have just x square. How to get rid of this 3 from numerator? You need subtract something. How much? Minus. Minus what? So that x square remains in numerator. Y square minus what? Leaves just a x square term in numerator. Suppose you subtract 1, what will happen? Only a part of this will get removed. Suppose you subtract 2, more will be removed. To remove exactly 3, how much must subtract? 3 by 2. Okay. Y square minus 3 by 2 will be x square plus 3 by x square plus 2 minus 3 by 2 will be common denominator x square plus 2, numerator x square minus 3 by 2 x square minus half x square. With this coefficient you need not worry, you can always adjust it, multiplying and dividing, doing something like that. Then constant term 3 minus will be cancelled. Agreed? So what you get as a result of subtraction of 3 by 2 is this much. Therefore, this numerator, this expression will be how much? That is what I have obtained, there is minus half x square by x square plus 2. So this will be root of minus 2 into minus 3 by 2. Take the minus sign, take the 2 inside. 3 minus 2y square. Perfect. Finished. You have attained a standard form. That's all. Okay. I could have separately calculated dx and obtained suitable replacements for the various factors also. That's also possible. That requires a little more, few more calculations. I could have found x square from this equation, then found obtain an expression for x, from there get dx, use that to replace dx, then find a suitable expression for this and go on, so on. Yes.
It should be x square plus 3, like y square equals substitution. X square plus 3.
Okay. Print mistake. Get it correct. Right. Correct. So, is the procedure clear? I am not arguing that this is one of the best or better methods of evaluating the integral. Let us have a knowledge about other possibilities. So, with that objective, that substitution has been told. Okay. One other substitution also is workable in a situation like 1 by ax square plus b into root of cx square plus d. Have you noted down our suggestions, yesterday's suggestions? What is the other one? There again one mistake might have been occurred. Let me write. If the situation is dx by ax square plus b into root of cx square plus d, one other usable substitution is, depending on the sign of d, if d positive, x is equal to root of d by c tan theta, and if d is negative, x is equal to root of, it must be minus d by c. We are assuming d is negative, otherwise root of d by c will not have meaning. Okay, minus d by c, what function? Secant theta. Let me consider both cases. First I will consider an expression of that form with d positive. Same you may reuse. So I will be trying now. X is equal to root of d by c. This is d, this is c, root 3 tan theta. C is 1. I integral takes the form dx is root 3 secant square theta d theta. X square plus 2 will be 3 tan square theta plus 2. And root x square plus 3 will be root of 3 tan square theta plus 3 root of 3 secant square theta equal to root 3 secant theta. On simplification, secant theta divided by 3 tan square theta plus 2. How can we get this integrated? We may switch over to sine and cos. Let us have everything expressed in terms of sine and cos. And to get that expression simplified, I will multiply numerator and denominator by cos square theta. Numerator into cos square theta is cos theta. Denominator into cos square theta is 3 sin square theta plus 2 cos square theta. Have we attained a well-known form, a form that has been already handled? Yes. What we do? Write this as, not this, write this as 1 minus sin square theta, get the denominator, whole thing in denominator as a function of sin theta, apply sin theta equal to t cos theta d theta dt. Good. Next, use of this substitution. For that I need d to be negative. I will consider minus 3 here. The substitution we can use now is x equal to root of minus d by c secant theta. Minus d is 3 by c is 1 secant theta. When you apply the substitution, integral becomes dx is root 3 secant theta tan theta d theta. X square plus 2 is 3 secant square theta plus 2. And root of x square minus 3 is root of 3 secant square theta minus 3 root of 3 tan square theta, am I right, is equal to root 3 tan theta. Remove root 3 tan theta from numerator denominator, express everything in terms of sine and cos. Multiplying numerator denominator by cos square theta, numerator becomes cos theta, denominator becomes 3 plus 2 cos square theta. Over. Next additional substitution suggested is for an expression of the form root of x minus alpha by x minus beta. And the substitution usable is x equal to alpha cos h square theta, is it not? Or cos h theta? Cos h square theta minus beta sin hyperbolic square theta. We can even think of secant square and tan square, alpha secant square minus beta tan square, but this I think is a little bit more easy to apply. Consider any one situation of that form, any alpha and beta, assign any pair of values for alpha and beta, values of your choice. Okay, 3 and 4. put x equal to 3 cos hyperbolic square theta minus 4 sin hyperbolic square theta. X minus 3 will be this minus 3 cos h square theta minus 3 minus 4 sin h square theta. 3 cos h square theta minus 3 is 3 into cos h square minus 1 is 3 sin h square minus 4 sin h square is minus sin h square. Don't worry about this negative sign. You are going to get the same sign in denominator radical under the denominator radical sign also. X minus 4 is this minus 4 3 cos h square theta minus 4 sin h square theta minus 4 is 3 cos h square minus 4 into within brackets 1 plus sin h square, but 1 plus sin h square is cos h square. So 3 cos h square minus 4 cos h square 1 cos h square with the negative sign. 1 plus sin h square is cos h square. Then dx. Dx will be 3 into 2 6 cos h theta sin h theta minus 4 into 2 8 sin h theta cos h theta. 6 cos h theta sin h theta minus 8 cos h theta sin h theta is minus 2 cos h theta sin h theta d theta. Yes. Negative signs cancel. Root cos h square theta cancels against this. Root sin h square theta into this sin h theta, you will be getting sin h square. So integrand becomes minus 2 into sin h square theta d theta. How do you get this integrated? Okay, use of the identity between or identity for cos hyperbolic 2 theta. If you remember it, fine. Otherwise, simply recollect the definition of sin h, e power x minus e power minus x by 2. When you square it, it becomes e power 2x plus e power minus 2x by 2 minus 2 in numerator. That is cos h 2 theta minus 1. Okay, half of that. You can use that. Write that in place of sin h square, carry out integration. Next step will be finishing of the job, writing down the integral itself. Or you may simply rewrite this in terms of e power theta and integrate there itself. No need to go back even to cos h. E power theta minus e power minus theta by 2 whole square, write the expansion of that, carry out term by term integration. Okay, then the question arises, how do you get back to x? Let me finish the job. Okay, what is an equivalent of 2 sin h square? Cos h 2 theta. No, I will express in terms of hyperbolic only because I have to get back to x. Cos h 2 theta minus 1, is it? Yes. Yes, right. Integrating plus 1 d theta integral is theta minus half of sin h 2 theta plus a constant of integration c. Now getting the answer in terms of x. What is theta in terms of x? Bring this expression into a form where only one kind of hyperbolic function appears, writing either this as 1 plus sin h square or this as cos h square minus 1, using any one of the two. Suppose you are retaining cos h and removing sin h. This is sin h square is cos h square minus 1. So left hand side will be here is my expression. Left hand side will be 3 cos h square minus 4 into cos h square minus 1, 3 cos h square minus 4 cos h square minus 1 cos h square, then one other term minus 4 into minus 1 plus 4. So, x becomes cos h square theta minus 4, reverse, 4 minus cos h square theta. Am I right? X is 4 minus cos h square theta. So, cos h square theta is 4 minus x. Yes, cos h square theta is 4 minus x. Therefore, cos h theta is root of 4 minus x. Theta is cos h inverse root of 4 minus x. There is another way to describe inverse hyperbolic functions. You can express this in terms of logarithmic functions also. You can also make use of that if you want. For example, sin h inverse x expression is
log of x plus root of 1.
yes, right, x square plus 1 or x square minus something like that you will have. Similarly, there is an expression for cos h inverse theta. You can use it if you want it expressed in terms of log function. Coming to this, what is an equivalent of this? Let me break it using the identity for sin h2 theta. Sin h2 theta, is it 2 sin h theta cos h theta? Sin h2 theta is nothing but e power 2 theta minus e power minus 2 theta by 2. Can't you write e power 2 theta minus e power minus 2 theta as e power theta plus e power minus theta into e power theta minus e power minus theta? That gives you, this is 2 sin h theta cos h theta, 2 cancel, leaving sin h theta into cos h theta. What is cos h theta? Just now we have obtained root 4 minus x. What is sin h theta? Let me express everything in terms of sin h. This is 1 plus sin h square, 3 plus 3 sin h square minus 4 sin h square, 3 huh?
We have cos h theta already. Directly we get sin h theta. 1 plus sin square theta.
It is equivalent to this. It is almost same as finding x from this form, sin h theta from this expression. This is 1 plus sin h square theta. So, expanding I get 3 minus sin h square theta. Sin h square theta is 3 minus x. Correct? Sin h theta is root of 3 minus x. Okay. Next, this kind of substitution is usable in another case also. That is when you have the integrand as root of x minus alpha into x minus beta. Is it applicable even when the reciprocal is the integrand? No, for that we have a different expression. Okay. The only change that will take place now is, instead of getting this by this, you will be getting this into this, rest same. So, now in this case, this cancellation will not take place. Instead, this will appear in the numerator, multiplications will take place. The integrand will not get reduced to this much simple function. Instead, you will have one more factor, that will be cos h theta you have removed. Now, removal will not be possible. This cos h theta will be in numerator, cos h square theta. So, it will take the form minus 2 into integral sin h square cos h square d theta. This may be written as square of sin h cos h, which is half of sin h 2 theta. So, you will be getting this as square of sin h square 2 theta, which is cos h double angle or double number plus 1 divided by 2, then carry out term by term integration. Procedure will be similar, but slight higher amount of degree will be here. So, reduction will be requiring one more step. Okay. Next type. Next type is reciprocal, 1 by root of x minus alpha into x minus beta. The substitution suggested is one is x minus alpha equal to t square, another is x minus alpha divided by x minus beta equal to y square. That's all, only two ways. I think this will be the most convenient substitution to evaluate an integral of this form, provided the expression quadratic under radical sign is factorizable. If it is not factorizable, this method doesn't work. You have to depend on method of completing squares. But when it is factorizable, this may be an ideal approach. Let me try. You may have this alpha positive also. You need not have x minus 2, x with the negative constant with the negative sign. This may be x plus 2 into x minus 3 also. This may be x plus 2 into x plus 5 also. For all such values, the substitutions, both the substitutions will be working. If you want, let me have this as x plus 3, no problem. We apply x minus 2 equal to t square, or x plus 3 equal to t square, whichever you like. Okay. Integral becomes dx is 2t dt, root x minus 2 is t, root x plus 3 is t square plus. Is it clear? Immediate. Integration is immediate. Even if you apply the other substitution, available substitution, x plus 3 equal to t square, integration will be equally simple. But this advantage you have only when this is factorizable quadratic. Otherwise, depend on method of completing squares only, no option. Okay. The other substitution next. In the same situation, we will be trying x minus 2 by x plus 3 equal to y square. Or 2y dy equal to x plus 3 whole square denominator, x plus 3 into 1 minus x minus 2 into 1, x plus 3 minus x minus 2. 5 dx by x plus 3 whole square equal to 2y dy. We will be applying these substitutions in the integral given. The integral will become, let me first rearrange the terms of the integral. First let me prepare myself to bring in this. I need 5 by x plus 3 whole square dx, in order that I may bring in 2y dy. In addition, I will need a y in denominator. What is y in terms of x? Is square root of this. That means I will require together with this root of x plus 3 by x minus 2 to bring in dy. Agreeable? This is as good as having 1 by y as one of the factors. So, this thing becomes 5 by y into x plus 3 whole square. 5 by y into x plus 3 whole square will be simply 2 dy. Agreed? Okay. Now adjust the other things. Have we covered this root x minus 2 completely? Yes. What about root x plus 3? Instead of writing root x plus 3, we have written x plus 3 to the power 3 by 2 in the denominator. How do we adjust? Writing x plus 3 x plus 3, just x plus 3 in numerator. This is root x plus 3 by x plus 3 whole square means x plus 3 to the power 3 by 2. Our requirement is half. So, extra is x plus 3 power 1. That will have to be written in numerator. Now, adjustment of constants divided by 5. Is it perfect now? 5 cancel. X plus 3 into root x plus 3. After cancellation will leave you root x plus 3 as desired. Then dx. Okay. This is 1/5 of this whole thing is 2 dy. Now it remains to find a replacement for x plus 3. What is x plus 3 if this is y square? What is an equivalent of x plus 3? 1 by 5 into 1 minus y square. Okay. How did you get it?
I got it as 1 minus 5 by x plus 3 is equal to y square.
One second. I will just give my explanation. Later you find out whether the two explanations agree or yours is different. Okay. What I do is, I want this x plus 3 as one of the factors to remain. I will retain this. From numerator, I want to remove x. What do I do? Simply subtract 1 from two sides. On subtraction of 1 from two sides, I will be getting a fraction with denominator x plus 3, numerator minus 2 minus 3, that is minus 5. From this, it is clear that x plus 3 is equal to minus 5 by y square minus 1. Agreeable? Minus 5 by y square plus 1. Sorry, minus 1. Finished, right? Yes. Next type. Root of x minus alpha divided by beta minus x. And substitution suggested. Is the substitution applicable only for this or more types covered? More types are there. What are those other types? X minus alpha into beta minus x. And reciprocal 1 by root of x minus alpha into beta minus x. For all the three, the substitution that we are going to write will be applicable. That substitution is alpha sin square minus beta cos square plus beta cos square. Okay. One situation I will consider and it will describe all the cases. Root of x minus say 2 divided by x plus 1. I will be applying the substitution x equal to 2 sin square theta. Sorry. This should be beta minus x. Okay, 3 minus x. X should appear with the negative sign. Constant term may be negative positive, but x must have a negative sign. Okay, 2 sin square theta plus 3 cos square theta. Integral will become root of x minus 2, this minus 2. 2 sin square theta minus 2 is minus 2 cos square theta. Minus 2 cos square theta plus 3 cos square theta, cos square theta. 3 minus x, 3 minus this thing, 3 minus 2 sin square theta minus 3 cos square theta. 3 minus 3 cos square theta is 3 sin square theta, minus 2 sin square theta is 1 sin square theta. Derivative dx is 4 sin theta cos theta minus 6 cos theta sin theta d theta. 4 minus 6 minus 2 sin theta cos theta d theta. Root sin square theta, sin theta cancel. Root cos square theta into cos theta will become cos square theta. Our integrand will be a numerical multiple of cos square, which may be written as 1 plus cos 2 theta by 2, carry out integration. Instead of having quotient, suppose you get the product x minus alpha into beta minus x, then this sin square theta will be found here. Then cancellation won't take place. Instead, multiplication will take place. Integrand will become sin square theta cos square theta. Again, you know method for reducing: sin theta cos theta whole square, constant into sin square 2 theta, one more reduction, cos 4 theta plus 1 divided by 2, next integration. Suppose you have everything in denominator. This cos square also is in denominator. Sin theta, cos theta, everything cancel, become integral number into d theta, finished. Next case is final one. Sorry. Any one of the two, x minus alpha by x minus beta or x minus beta by x minus alpha, any one of the two ratios may be called y square. Particularly useful, the method is particularly useful when m plus n is equal to minus 2. It is usable in other cases also, but in that situation the integrand becomes takes a too simple form when this substitution is tried. Example. Do I get m plus n equal to minus 2? Yes. A simpler case, simple case. Two y dy will be quotient with denominator x plus 3 whole square, numerator x plus 3 into 1 minus x minus 2 into 1, 5. That is dy equal to 5 by 2 into dx by, this will remain. In addition to that, one y also will come to the denominator. What is y in denominator? It is nothing. Yes. Root of x plus 3 divided by root of x minus 2 into x plus 3 whole square dx. Or it is 5 by 2 into dx by x minus 2 to the power half into x plus 3 to the power 3 by 2. What do you notice now? Yes. Entire job is just calculation of this dy, expression for dy. ಎಷ್ಟು 2 by 5 or 5 by 2? 2 by 5. Next, a more general case, a case where m plus n is not minus 2. We may have to slightly struggle a bit in order to get the integration performed, but the substitution will work then also. I am making this index, minus half better. Minus half means, okay, let it be, no problem. No problem. Let us, just for a change, consider this. Now also substitution I am preferring is the same. So an expression for dy will be this only. Okay. Before applying the substitution, let me prepare myself for applying this. I require, in order to bring in dy, I require this much separately kept there in the integrand. So this, let this part remain separately. This much I require to bring in dy. Now, what things remain uncovered? This has been wholly covered. Instead of having x minus 2 to the power minus half, we have written x minus 2 to the power plus half. How do we balance? We will write x plus 2 in the x minus 2 in the numerator. That will be equivalent to having x minus 2 power minus half in the denominator. Then adjustment of constants. Okay, that we need not try. Let us have this much of preparation. Then, now how to bring in x minus 2? How to get this in terms of y? Your expression for y square is this. You need x minus 2 to remain. Let me take reciprocals. 1 by y square becomes x plus 3 by x minus 2. I want this to remain and I want to get this eliminated. What do I do? Subtract 1. Subtract 1 from both sides. As a result, right side will become 5 by. Now I am able to find a replacement for x minus 2. That replacement is 5 by 5 y square by 1 minus y square. Right. And what is the replacement for this? This much, 2 by 5 dy. Right? Yes. Are you familiar with this kind of situation? Yes. What do you do? This is a rational algebraic fraction. How do you get this integrated? First reduce to proper form, then if necessary partial fractions, otherwise direct application of formula. No use of partial fractions needed, directly you can write the answer. First you have to perform division. Baidala complete model. Bidbodala. Yes. On substitution method, this much enough. All varieties, no, I don't claim all varieties have been covered, but most of the normally used varieties have been covered. Still, there may remain 1 or 2 types which might not have been covered by our different methods, but most of the varieties have been covered, and you have got now experience, you have now obtained or gained a good amount of experience. With this experience, I think you will be able to try more problems on your own. Okay. Substitution method, this much enough. Next method that is to be discussed by us, integration by parts. Number D ಅಂತ ಹೇಳ್ಬೋದು ನೆನಪಿದೆ. This is a direct application of our product rule of differentiation. For a product of two functions, we know derivative is first function into derivative of second plus second function into derivative of first. D by dx of uv is u into v dv by dx plus v into du by dx. Simply integrate the two sides with respect to x, knowing that, keeping in mind that integration is reverse procedure of differentiation. So when you integrate, integration and differentiation, these are inverse procedures, cancel against each other, leaving uv. This becomes integral of u into dv by dx. And here we will be getting integral of v into du by dx. Okay. Now slight renaming of the terms involved. Let me name this as capital U and this as one function. Okay, let me name this as capital V. So I am renaming small u as capital U and dv by dx as capital V. In my new terminology, equation becomes, this is capital U only, small v, dv by dx is capital V, so small v will be integral v dx. Agreed. Is equal to, this is integration of small u and capital U are one and the same. This I am renaming as v dx. I am not disturbing the definition of x. X remains same. Only the function names have been changed. Plus integral of, this is small v, dv by dx is capital V, small v will be integral capital V dx, and small u, capital U are one and the same. Du by dx is d by dx of capital U dx. Or rearranging the terms, we get integral uv dx, integral of a product is first function into integral of the second minus integral of derivative of the first into integral of the second dx. This is the rule of integration by parts. For a product of two functions, integral of the product is first function into integral of the second minus integral of derivative of the first into integral of the second into dx. The form may hint us that this is applicable whenever our function to be integrated is a product function. In actual practice, it is, the answer is no, in the negation. It is not to be applicable, to be applied whenever you find the integrand to be, whenever you find the integrand as a product function. Sometimes integrand will not be seen as a product function, but the method of integration by parts will have to be used by you. Sometimes integrand will be given as a product function and you will not use this, instead you will depend on some other method to perform the integration. Just because rule says integral of a product equal to something, do not try to apply this whenever you find the integrand to be a product function. Only in select situations this rule must be made use of, not always. So basic form of the rule of integration by parts is integral of a product is first into integral second minus integral of derivative of first into integral second. Okay. Suppose you have a situation where rule of integration by parts is convenient to apply. For example, one case may be x e to the power 2x dx. None of the other methods is applicable now. You cannot obtain the integral by direct use of a standard result. You cannot obtain the integral by decomposing the integrand. Decomposition is not possible. You cannot think of applying a substitution and get the integrand simplified. You will have to depend on method of integration by parts. Then the question arises, can any of the factors be chosen as first function and the other part second function? My rule says integral of a product is first into integral second minus integral derivative of first into integral second. The positions of the first and second are not symmetric. One of the functions gets integrated, another one of the functions gets differentiated. So you cannot randomly select one of the functions as first function and another one as second function. You will have to make the selection carefully. One rule, I don't have any logical explanation for this, but practically it works. A rough rule that may be used is means if you find as one of the factors in the integrand a logarithmic function, give it highest priority. Next priority goes to inverse trigonometric functions. Next priority goes to algebraic functions. Next priority trigonometric functions. Next priority exponential. In the process, all elementary functions are covered. So highest priority for logarithmic, lowest priority for exponential. We have two factors here, one algebraic, one exponential. Higher priority goes to algebraic. That will be our first function. Lower priority function e power 2x will be our second function. That way we will apply the rule of integration by parts. In most of our applications that works. There may be rarely one or two situations which you can easily remember where it may fail, but in most of our problems this rule works. I do not know why it works, but it works. I know that it works. Okay. Shall we finish this? First function into integral of the second minus integral of derivative of the first one, integral of the second this much dx. And so your answer will be half x e to the power 2x minus e to the power 2x by 4. Next, before taking up more problems on integration by parts, in some cases, in this case I could get the answer, I could get the integral by just one application of the rule of integration by parts. But in some cases you may have to apply the rule again and again in more than one time. For example, if the situation is x to the power 3 e to the power 2x dx, in the first application you will get integral of derivative of the first becomes 3x square into integral second. Integration process will not be complete. Next, once again you will have to apply integration by parts method, then this will get reduced to expression of degree 1. One more application will finally give you the answer. So more than one time you may find the necessity of applying the rule. Then for your convenience there is an extended form of this rule of integration by parts also. I will be stating that. Suppose for convenience, let this denote the nth order derivative of u. So u, one written as exponent within brackets will mean first derivative, 2 written here means second derivative, d square u by dx square, 3 here means third derivative, so on. Let this denote dn by dxn of u, nth derivative of u. And only for our convenience, let this denote, we are writing the number as a suffix, n times the function integrated successively n times. Means you integrate u, again integrate what you have obtained as integral, again integrate that once with respect to once again n times like this, you successively continue that expression. I will be denoting by this symbol just for my convenience. These are not standard abbreviations, the standard symbols, only for our convenience. Then our rule states integral uv dx is equal to first function into integrate the second minus differentiate the first, integrate this once again, plus alternately positive negative signs, differentiate this, integrate this, next minus sign, differentiate this, integrate this, continue like this indefinitely, alternately positive and negative sign. Each time I will be differentiating the first factor and integrating the second factor. It is a simple extension of this. You just apply once again rule of integration by parts to this, you get this second term. One more application gives you the third term. Like that you can continue indefinitely. Normally we use this in a situation where this first part will, derivative will vanish after certain stages. This you go on differentiating. Third derivative will be constant. Fourth derivative will be 0. So the process will end at the third place. Okay. Useful extended form of the rule of integration by parts. To illustrate, let me consider this example. First function, integral of second e power 2x by 2 minus derivative of the first into integral of the second e power 2x by 4. Only thing is, in between you must not perform simplifications. You must not think of writing this 3 by 4 outside. This will have to be retained with this. This will have to be retained with this. You must not disturb the positions of the constant factors, because next time what you have to differentiate is 3x square, not just 1x square. Derivative will be 6x. Similarly, the function to be integrated will be this, not just e power 2x. The integral will be e power 2x by 8. Remember that. All simplifications will be performed only after finishing integration. Okay. Next term, plus 6x into e power 2x by 8. Next term, minus 6 into e power 2x by 16. Is the process finished? Yes. Plus c. If you try to write the next term, derivative will be 0. Okay. So what is that you have obtained? X cube e power 2x by 2. Now you can carry out simplifications. 3x square e power 2x by 4 plus 3x e power 2x by 4 minus 3 e power 2x by 8 plus. If you have any doubt over the method, differentiate it. You will find that the derivative is x cube e to the power 2x. All we will not be trying. I am just listing out. a very simple application. Which will be chosen as the first function? X. First function into integral of the second minus integral of derivative of first integral of the second sin 3x by 3 dx. Next step, x sin 3x by 3 minus integral sin 3x minus cos 3x by 3, add a constant of integration because the job has been finished. Has already been tried. Okay. Which function will be given first preference? Log. Log 2x into. You need not worry that when you integrate, the degree is going to increase. No, in the next step it will get reduced to a smaller number. Integral x cube, x to the power 4 by 4 minus integral derivative of the first 1 by x. 1 by x into integral of the second x power 4 by 4 dx. No need to continue further. Sin root x. Before applying the method, I will make use of a substitution. Substitution I try will be root x equal to y, x equal to y square. Sin root x is sin y and dx is 2y dy. Now you proceed to apply integration by parts, taking y as first function, sin y as second function. Okay? We will not apply the rule of integration part by parts directly to this function. Before applying the rule, we will get the degree of this reduced. Using the identity for cos 2 theta, this sin square 3x is written as 1 plus cos 6x divided by 2. Then little bit of decomposition only to one of the two parts, integration by parts. Is this formula correct? 1 plus cos 6x, should it be 1 minus? 1 minus. Integral x by 2 is x square by 4 and the next part, integration of x cos 6x with respect to x will be obtained by method of integration by parts, taking x as first function, cos 6x as second function. Direct application of rule of integration by parts, taking 1 as one of the functions and sin inverse x as the second function, or apply substitution y equal to sin inverse x equal to sin y, dx will be cos y dy. You will see the function in a form suitable to use the rule of integration by parts. If I use 1 as one of the functions, first function will be sin inverse x, second function 1, integral is x minus integral of derivative of first is 1 by root 1 minus x square, integral second is x dx. Do you know how to finish this? Yes. Or alternately, use the substitution sin x equal to y. Your integral becomes y into x is sin y, so dx is cos y dy. Directly the rule of integration by parts is applicable, y first function, cos y second function. Only thing is, after finishing integration, you will have to get back to x. Again, same procedure, integration.
Sir, in the sin
Try. Do it, try it. Given according to my rule, LIATE, inverse is to be given higher priority than algebraic. Your 1 is an algebraic function. Okay. Okay, try first, taking 1 as first function. Direct application of rule of integration by parts. First function will be tan inverse x, inverse trigonometric function, into integral second x cube by 3 minus integral of derivative of first 1 by 1 plus x square, integral second x cube by 3 dx. How can we get this rational function integrated? Notice that it is improper. First it will be reduced to proper form, then integration. Same thing, instead of getting x cube by 3, we will be getting x square by 2. This will be x square by 2. Process will be little bit more simple. Even then the fraction is improper, but division requires only one step. Another situation where we do not find our integrand as a product, we will bring in one factor from outside. One will be taken as one of the functions, the existing function as one second function, and integration performed, taking one of the factors as 1. Even though the integrand is not found as a product function, rule of integration is usable. First function log of 1 plus x square, integral second is x, integral 1 is x, minus integral of derivative of first is 2x by 1 plus x square, integral second x dx. As second integrand, we are having a rational algebraic fraction, improper maybe, we can easily get it reduced to proper form, then integrate. Next, x cube into log x whole square. By looking at the expression, you may feel that this is a situation where you may have to apply the rule of integration by parts successively many times and may think of applying the extended form. But do not try that. You have to apply the rule only once. Do not go for the extended form in this case. Let us see what happens. Rule is applied only once. The first function is log x whole square. Second function integral is x power 4 by 4 minus integral of derivative of first 2 log x into 1 by x, integral second x to the power 4 by 4 dx. We will get this simplified before going for second application of the rule of integration by parts. If you try applying the extended rule, this will remain as your first function. You will not be simplifying anything before finishing the process. This will remain as your first function. This will remain as your second function. Differentiating this means use of product rule will be required. More terms will be coming in. Process will be getting more and more complicated. So, in a situation like this, when log x is found as one of the factors, we do not prefer to apply the extended form. That is used only when trigonometric functions appear as part of the function. X, say x power some higher number into sin 3x or cos 3x. In such situations, use the extended, not here. Two by 4 half of integral x cube log x. One more application gets the integrand simplified to a larger extent. First function is log x, integral second is x power 4 by 4 minus integral derivative of first is 1 by x, integral second is x power 4 by 4 dx. X cos inverse x. You can directly apply rule of integration by parts, taking cos inverse x as first function, x as second function. Or you may also think of applying substitution, cos inverse x equal to y, x equal to cos y, this will be cos y, this will be y, and what will be dy? Minus sin y dy. Then proceed to apply rule of integration by parts. Any method is okay. I apply the rule directly. First function will be cos inverse x, second function x integral is x square by 2 minus integral derivative of first minus 1 by root 1 minus x square, integral second x square by 2 dx. How do we finish this integration? Dividing. Write the numerator minus x square as 1 minus x square minus 1. 1 minus x square by root 1 minus x square is root 1 minus x square, standard function. The other part will be minus 1 by root 1 minus x square, another standard function, integral being sin inverse x. Tan inverse x integration, taking 1 as one of the functions, 1 into tan inverse x. Sin inverse root x, first you use a substitution, x equal to y square, then proceed. Did we try this already? Yes, over. Oh, I wrote the problem twice. Okay. Lastly, secant cube. This I need not try, I think. Okay. Last, secant cube. I think the earlier problem tried was not sin inverse x, it was sin root x. This is sin inverse root x, different one. But this also workable using the same idea, root x equal to y square. Root x equal to not y square, y, x equal to y square. So my function becomes, or let me have the whole thing as y. My function integrand becomes y into dx. What is dx? Root x is sin y, x is sin y square. Am I right? X is sin y square, so dx is cos y square into 2y dy. Huh? Huh? Correct. I got my mistake. This means root x equal to sin y. So x will be sin square y, not sin of y square. Okay. Correct. So what should I write? Sin, let me start from beginning. Sin inverse root x is y. Next I want a replacement for dx. Root x is sin y, x is sin square y, dx is 2 sin y cos y dy. Or this will be y sin 2y dy. Just one application of rule of integration by parts. Last, secant cube. Yes. Secant square into secant. Okay, we will try. Which of the two will be chosen as the first function? Which is easier to integrate? You choose it as second. The other one will be our first function. Differentiation is always simple. Any function you can think of differentiation, but integration not that easy. So the one which can be easily integrated will be our second function. First function is secant x, second function integral is tan x minus integral. Derivative of first function is secant x tan x, integral of second function is tan x dx. This is secant x tan x minus integral of, how to integrate secant x tan square x? Okay. Okay. Then, right, you are on the right direction, yes. You will be getting a secant cube, we will shift it to this side. Correct. Minus secant x into tan square x is secant square x minus 1 dx. One of the terms we find is secant cube, that will be shifted to this side. So on this side we will have 2 into integral secant cube x dx being equal to secant x tan x minus remaining term minus of minus secant x dx. Integral secant x dx is well known to us, log of secant x plus tan x. Dividing by 2, you are getting your integral. Okay. Next, to finish the job on integration by parts method, one more particular case of the rule of integration by parts. Suppose you have an integrand in the form e to the power x into some arbitrary function f of x plus its derivative f prime x dx. What will be the integral then? E to the power x into f of x. How do you obtain this? There are two ways. Knowing this, verifying is simple. Simply differentiate this, you will find this as the derivative. Without knowing the right side, how do you derive it? Keep one of the terms as it is. Consider the other term e power x into f dash x. For that, apply the rule of integration by parts, taking e power x as second function, f prime x as first function. No. F prime x as second function, the function to be integrated, and e power x as the first function. The second term you obtain the integration will cancel against this, leaving that expression on the right hand side. Derivation is too simple, I will not go through that. Some applications. Answer. Direct answer. E power x by x. He says x by x square, 1 by x minus 1 by x square. For f of x equal to 1 by x, minus 1 by x square is a derivative. Application of the theorem, answer e power x by x. Any answer? Immediate answer? This x in numerator may be imagined as x plus 1 minus 1. X plus 1 by x plus 1 whole square is 1 by x plus 1. Other term will be minus 1 by x plus 1 whole square. For 1 by x plus 1, minus 1 by x plus 1 whole square is derivative. Answer will be e power x into 1 by x plus 1. Sin 2x is 2 sin x cos x. 2 sin x cos x by 2 cos square x is just 1 tan x. Okay. This 2 by 2 cos square x is secant square x. One term is tan x, other term is secant square x. Integral is e power x into tan x. Dx is here. Let me leave the denominator as it is. Expand 1 minus x whole square of numerator. It will be 1 plus x square plus 2x. Huh? Minus 2x. I may write this as e power x into 1 plus x square by 1 plus x square whole square 1 by 1 plus x square minus 2x by 1 plus x square whole square. Just to check, is this the derivative of this? Yes. So integral is e power x by 1 plus x square. Next, one final application of this final last result. So far I was helping you. It helped you in many cases. Now in the last problem you should help. You are not finding e power x. How will you proceed? Okay, did I miss that factor? No. Everything is in perfect order. Okay, this may not be application of that result, may be a simple application of our normal rule of integration by parts. Maybe that. Okay, why should I misdirect you? No. If you are trying to apply rule of integration by parts, how do you imagine the integrand? Which will be your first function, which will be your second function, which you will be choosing as first, which you will be choosing as second. To apply, yes. Are you choosing the functions randomly?
X square as second function and the whole 1 by x as first.
You have the. You may have to. You will have to perform differentiation of this. Are you ready for that? See, when you are going to apply the rule of integration by parts, you should identify two factors, and one of them must be easier to find, easier to integrate. The other part you need not give too much importance. It will be differentiation, can be always done. This part must be easily integrable one. Then only you can think of proceeding, choosing that as the second function. You choose which one you are choosing as first function? 1 by this whole square. Integration may be simple, but afterwards differentiation and after effects, how to deal with them. What is derivative of x sin x plus cos x? Derivative of x sin x plus cos x. X into cos x plus sin x minus sin x. Is it just x cos x? X into cos x plus sin x into 1 minus sin x. X cos x. Now this part will be easily integrable. Adjust. What is not covered? X. What is introduced, brought from outside? Cos x. Okay, I think. Yes. I will choose this as first function, this as second function, try integration. First function, x by cos x, integral of second, dt by t square dt. This is, if I call this t, this will be dt. That's how I have obtained this numerator. Okay, dt by t square dt is t power minus 2 integral t power minus 2 t power minus 1 by minus 1 minus 1 by t. Okay. Minus first function into integral of second minus integral of derivative of first, derivative of x by cos x. Let me treat it as, instead of treating it as a quotient, let me treat it as x into secant x, so that differentiation becomes a little more simple. Derivative of x secant x is x into secant x tan x plus secant x. This is derivative of first into integral of second minus 1 by x sin x plus cos x dx for the second integration is minus x by cos x into x sin x plus cos x minus of minus plus. Try some simplifications before proceeding. What is secant x tan x? This is sin x by cos square x. This is 1 by cos x. Take common denominator cos square x. It becomes x sin x plus cos x. Agree? X sin x plus cos x, x sin x plus cos x cancel, leaving only the denominator. What was our denominator? Cos square x or secant square in numerator. Integration by parts is finished. Next, final method available for us for carrying out integrations is use of reduction formulae. Not all sorts of problems workable under the use of reduction formulae method will not be discussed by us. I want you to just get introduced to the method. So some simple examples we will be dealing just to give you a taste of that method of use of reduction formulae. Only a few cases I have chosen the problems. Here if one of the indices is odd, there will be no need to go for use of reduction formula method. If this index is odd, for example, You may write this as sin power 10 into cos power 16 into cos x, and cos power 16 is obtainable in terms of sin x alone. You can apply the substitution sin x equal to t and finish the job. If one or both of the indices are odd, the integration will be a very simple exercise. But if both are even then, if the indices are small, we can continuously go on reducing the function, reducing the degree of the function. Finally, we may arrive at a linear function, then carry out integration. If high indices are there like this, then we will have to depend on reduction formula. Similarly, reduction formula necessary may be avoided with the use of substitution x equal to 2 tan theta. But when you actually apply the substitution, you will attain a stage where the integrand will involve one of these two types of functions, and again you will have to return to use of reduction formula method. Directly, why not directly apply reduction formula and finish the job there itself? Okay. What I do is, I consider a general integral of that form first, x square plus 4 to the power n. You need not make it most general. By considering x square plus a square power n, one constant you may retain, only the index let it take a general value. How to obtain a reduction formula for this? I will apply method of integration by parts. Most of the reduction formulae are derived by applying the same rule of integration by parts. In most of the cases, deriving reduction formula depends on rule of integration by parts. Here also I will apply that only, taking 1 as one of the functions. First function, 1 by x square plus 4 to the power n, integral of the second x. Second is 1, minus integral of derivative of the first minus n into x square plus 4 to the power minus n minus 1. Correct? N minus 1 or n plus 1? N plus 1 into derivative of x square plus 4 2x into integral of second dx dx. This much is derivative of first, and this is integral of second. This is x by x square plus 4 to the power n minus of minus 2n into, I am getting x square by x square plus 4 to the power n plus 1. I will write the x square in numerator as x square plus 4 minus 4, so that little bit of simplification I can apply. As a result, the integrand becomes x square plus 4 by x square plus 4 to the power n plus 1 is 1 by x square plus 4 to the power n minus how much? 4 by x square plus 4 to the power n plus 1. Am I right? Writing the x square in numerator as x square plus 4 minus 4. Okay, I think. Yes. Notice that the last term in the right hand side is of the same form with which we started our exercise. No, not of the same form, but is of a higher degree, same form, higher degree. I will shift that term to this side and transfer this term to the other side, so that I can club this integral with this integral, and I will have a higher order integral of the same form on this side. Okay. As a result, I will have integral dx by x square plus 4 to the power n plus 1 equal to, I am getting coefficient 8n there. To get rid of that coefficient, I will have to divide by 8n, 1 by 8n into first term x by x square plus 4 to the power n plus this shifted to the other side is 2n minus 1. Am I right? Divided by this coefficient 8n integral dx by x square plus 4 to the power n. Sari unta ella? No, there is a mistake. Intentionally committed mistake.
This is 2n by 8 and minus.
Plus 1. Will it be okay now? No. Actually, earlier we were right. Now you have made me commit a mistake. I wanted this. Okay. Everything is perfect with this itself. This is the reduction formula for evaluating any integral of this form. You start with the integral of order n plus 1. Use of the reduction formula helps you in reducing the order of the integral by 1. So, using that here repeatedly, what do we get? Apply the formula. You have the index 5 here. Apply this reduction formula with n equal to 4. For n equal to 4, this will be that integral. Okay? We apply this with n equal to 4. We get 1 by 32 x by x square plus 4 to the power 4. Right? Plus 2n minus 1, 8 minus 1, 7 by 8n 32 into integral of, we will get dx by x square plus 4 to the power 4. Again I will apply this formula now with n equal to 3. When you apply this with n equal to 3, you will get 1 by 24 x by x square plus 4 to the power 3 plus n equal to 3. 2n minus 1 is 5 divided by 24 into integral of dx by x square plus 4 to the power 2. Now index has got reduced to 2. Apply the formula once again. 2 or 3? I don't know. 3. ಇಲ್ಲಿ 8 into 3 24 ಅದಲ್ಲ, ಇದು 8 into 3 24 ಅದಲ್ಲ, n used was 3. So you will be getting dx by x square plus 4 to the power 3. Now again we apply this formula with n equal to 2. N value will be 2 in the next application. We will get 1 by 16 x by x square plus 4 whole square, n is 2, plus 4 minus 1, 3 by 16 integral of, what is our n? 2 now. You just compare this, 8n equal to 16, n equal to 2 now. So we will have inside integral dx by x square plus 4 whole square. One more application of the same rule, now with n equal to 1. Index is 2, so n will be 1. For n equal to 1 I get, the process must end now. I do not have any simpler kind of bracket, all brackets are used now. X by x square plus 4. N is 1, no? No, no, no. N is 1. 8n, 8 equal to 8 means n is 1. Plus n is 1. So 2 minus 1, 1 by 8 into integral of n is 1 dx by x square plus 4 power 1. Dx by x square plus 4. ಎಷ್ಟು 1 by 2 tan inverse x by 2. Simplification, you must remove the brackets and write. This is how a process works with the help of a reduction formula. Okay, next a trigonometric function. The function to be integrated is sin to the power 10x. A general form of the integrand is sin to the power mx, where m is an integer, positive integer. We will derive an integration reduction formula for sin to the power mx, which will later be repeatedly used in the evaluation of this. How to derive a reduction formula? Method of integration by parts. In the previous case, we applied the method taking 1 as one of the functions. There is no necessity to take 1 as one of the functions. Instead, we may treat this as sin power m minus 1x into sin x, sin power m minus 1x into sin x, and take that second factor sin x as the second function. Okay. First function sin power m minus 1x, integral of the second integral sin x minus cos x minus integral of derivative of the first m minus 1 into sin to the power m minus 2 into derivative of sin cos x. This much is derivative of the first function, to be multiplied by integral of the second minus cos x dx minus of sin power m minus 1x cos x minus of minus m minus 1 constant into integral of sin to the power m minus 2x into cos square x. In the original form, we had only sin. In this reduced form, I am having both sin and cos, which is certainly not preferable. Change the form of the second factor. Try to obtain this as a function of sin alone, writing cos square x as 1 minus sin square x. We will get integral sin power m minus 2x dx minus, let me again write the coefficient, m minus 1 into integral sin power m minus 2 into 2 sin power mx dx. We transfer the last term to this side, divide throughout by its coefficient. That will be what we obtain, will be the reduction formula. When the last term is shifted to this side, coefficient becomes m. So, just m, is it not? So, we will have to divide throughout by m. Minus 1 by m sin to the power m minus 1x cos x plus m minus 1 by m integral of sin to the power m minus 2x dx. This is the reduction formula that can be used whenever you are required to integrate a function of this form. Okay. The advantage of this formula over the previous formula is by one application of the formula, index gets reduces by 2. In our previous case, it got reduced by only 1. So, if the index is 5, we had a necessity of applying the rule 5 times. Now, you will not have to apply it 10 times, 5 times application will be enough. ಏನಿಲ್ಲ, ಒಂದೊಂದೇ ಟರ್ಮ್ ಬರ್ತದೆ. ಒಂದೊಂದು ಅಪ್ಲಿಕೇಶನಲ್ಲಿ ಒಂದೊಂದು ಟರ್ಮ್ ಬರ್ತದೆ. ಲಾಸ್ಟ್ ಕೇಸ್ನಲ್ಲಿ ಅದೊಂದು ಇಂಟೆಗ್ರಲ್, ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಟರ್ಮ್. ಟೋಟಲ್ 6 ಟರ್ಮ್ಸ್ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್. ಈ ಫಾರ್ಮುಲಾ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್ ಡೆಫಿನೆಟ್ ಇಂಟೆಗ್ರಲ್ ಡೀಲ್ ಮಾಡುವಾಗ ಇನ್ನೊಮ್ಮೆ ಇದನ್ನು ರೀಯೂಸ್ ಮಾಡಲಿಕ್ಕೆ ಉಂಟು. ನನಗೆ ಇದಕ್ಕೆ ಲಿಮಿಟ್ ಹಾಕಿ ಒಂದು ಫಾರ್ಮುಲಾ ಡಿರೈವ್ ಮಾಡಲಿಕ್ಕೆ ಉಂಟು. ಆ ಫಾರ್ಮುಲಾ ಮುಂದೆ ನಮಗೆ ಡೆಫಿನೆಟ್ ಇಂಟೆಗ್ರಲ್ಸಲ್ಲಿ ಯೂಸ್ ಆಗಲಿಕ್ಕೆ ಉಂಟು. ವ್ಯಾಲ್ಯೂಸ್ ಫಾರ್ಮುಲಾದ ಒಂದು ಕೇಸ್ ಇದು. ಓಕೆ, ಇಂಟಗ್ರಲ್ ಸೈನ್ ಪವರ್ 10x dx minus 1 by m 10 sin power 9x into cos x plus m minus 1 9 by 10 into integral of sin power 8. Integral sin power 8 will be minus 1 by 8 sin power 7 into cos plus 7 by 8 integral of sin power 6. Integral sin power 6 will be minus 1 by 6 sin power 5 into cos plus 5 by 6 into integral of sin power 4. Integral sin power 4 is minus 1 by 4 sin cube cos plus 3 by 4 integral of sin power 2. Once you get sin power 2, do not again apply this reduction formula. You have an alternate approach. You can immediately finish the procedure, write that sin square x as cos 2x minus 1 by 2 and integrate. Okay. So, integral, now the integrand obtained is sin square x dx. It will be finished writing this as cos 2x minus 1 divided by 2, carrying out term by term integration. This will be similar, only thing is you require a different reduction formula. Okay. Can you derive it from here? You have already obtained the reduction formula for sin power m. Using this, can you derive a reduction formula for cos power m? Any idea? Not guessing. I want a derivation. Right. You replace this x by pi by 2 minus x. Sin of pi by 2 minus x is cos x. This will get converted to this. As a result, this dx will become, if the new variable is pi by 2 minus y, this dx will be minus dy. Notice that you have got an additional negative sign on this side. Remember it. Okay. Next, what happens to this? This will be cos power m minus 1x, and this will be cos of pi by 2 minus y sin y. No extra negative signs. And this constant, what about this? Let me record. ಇಲ್ಲಿ ಒಂದು ನೆಗೆಟಿವ್ ಸೈನ್ ಬಂದಿದೆ, ಅದನ್ನು ಇಲ್ಲಿ ತಗೊಳ್ಳುವಾಗ ಇದು ಪ್ಲಸ್ ಆಯಿತು, ಕಾಸ್ ಅಲ್ಲ, ಕರೆಕ್ಟ್ ಅಲ್ಲ, ಕಾಸ್, ಆ್ಯಂಡ್ ದಿಸ್ ವಿಲ್ ಬಿ ಸೈನ್ ಪ್ಲಸ್ m minus 1 by m into integral. Early apply x equal to pi by 2 minus y. This will become cos power m minus 2. What about dx? Will become minus dy. So, one negative sign here. This will be the reduction formula for cos power mx. Applying repeatedly, you can find value of cos power 10x. Okay. Last general form of this is sin power mx cos power nx. M and n may be different integers. I will just derive the reduction formula and leave it. Okay, I will not apply it to that situation. Just to derive the formula. We will use it later when we take up definite integrals. Any idea? You have to apply rule of integration by parts. So you have to imagine this as product of first and second function. Second function must be easier to integrate. Yes. I will treat this as sin power m minus 1x into cos power nx dx into sin x cos power nx into sin x dx. I find that this part is easily integrable through substitution cos x equal to t. Okay. Apply the rule of integration by parts, taking this as first function, this as second function. Into integral of the second. Cos x is t, sin x dx is minus dt. So it is t to the power n into minus dt. Integral is minus t power andre cos ala cos power n plus 1x divided by n plus 1. Correct? Yes. Minus integral of derivative of the first m minus 1 sin power m minus 2x into cos x. Integral of the second minus of cos power n plus 1x divided by n plus 1 dx. ಎಂತ ಮಾಡೋ ಡಿಗ್ರಿ ಹೆಚ್ಚಾಯ್ತಲ್ಲ. ರಿಡಕ್ಷನ್ ಫಾರ್ಮುಲಾ ಅಂದರೆ ಡಿಗ್ರಿ ಕಡಿಮೆ ಆಗಬೇಕು, ಆರ್ಡರ್ ರಿಡ್ಯೂಸ್ ಆಗಬೇಕು, ಡಿಗ್ರಿ ಹೆಚ್ಚಾಯ್ತಲ್ಲ. Treat this cos power n plus 2x as cos power nx into cos square x. Replace the cos square x by 1 minus sin square x. This is treated as cos power nx into cos square x. The second cos square x is replaced by 1 minus sin square x. As a result, it becomes sin to the power m minus 2x cos power nx minus sin power mx into cos power nx dx. We shift the last term to this side, divide throughout by the new coefficient. When that last term is shifted to this side, the coefficient will become 1 plus m minus 1 by n plus 1. What is 1 plus m minus 1 by n plus 1? M plus n by n plus 1. We have to divide throughout by that coefficient. Minus 1 by m plus n sin to the power m minus 1x cos to the power n plus 1x plus m minus 1 divided by m plus n integral of sin to the power m minus 2x cos to the power nx dx. This is a reduction formula which can be used in the integration of any integral of the form sin power mx cos power nx. In this reduction formula, I have given you a method to get the index of sin function reduced by 2. At each application of the formula, this index gets reduced by 2. So after certain number of applications, this will reach the value 0. At that point, you will have to stop applying this reduction formula, go for use of the reduction formula for cos power nx. apply that successively, go on reducing this index, and then finally arrive at cos power 2x. There you change your approach and finish the job. Okay?
Can we reduce to, it was 16 and 10, can we reduce 16 to 10 and combine 10 and 12?
Can we reduce 16 to?
10.
Huh.
Then apply this.
Which one?
Apply after combining sin and cos. Sin to x is 16.
ಪುನಃ ರಿಡಕ್ಷನ್ ದೊಡ್ಡ ಪ್ರೊಸೆಸ್ ಆಗೋದಿಲ್ಲ. ಸೈನ್ ಪವರ್ 10 ಕಾಸ್ ಪವರ್ 10 ಅಂದರೆ
Sin power 10 cos power 10 and sin 2x.
ಹಾಂ ಟು ದ ಪವರ್ 5. ಸೈನ್ ಪವರ್ 10 ಕಾಸ್ ಪವರ್ 10 ಅಂದರೆ ಸೈನ್ 2x ಟು ದ ಪವರ್ 10 ಸೈನ್ 2x ಟು ದ ಪವರ್ 10 ಸೈನ್ ಅದರ ಆ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ದ್ಯಾಟ್ ಯು ಕ್ಯಾನ್ ಡು. ಸೈನ್ ಎಕ್ಸ್ ಪವರ್ ಎನ್ ಇದ್ದು ರಿಡಕ್ಷನ್ ಫಾರ್ಮುಲಾ ಅದು ಒಂದೇ ಅಲ್ವಾ? ಸ್ವಲ್ಪ ಫ್ಯೂ ಸ್ಟೆಪ್ಸ್ ವಿಲ್ ಬಿ ಸೇವ್ಡ್. ಎಸ್ ಎಕ್ಸೆಪ್ಟೆಡ್. ರೈಟ್. ಬಟ್ ಅಲ್ಲಿ ನಾವು ಫಾರ್ಮುಲಾ ಡಿರೈವ್ ಮಾಡಿದ್ದು ಸೈನ್ ಎಕ್ಸ್ ಪವರ್ ಎಮ್ಮಿಗೆ, ಸೊ ಇನ್ನೊಂದು ಸೈನ್ 2x ಪವರ್ ಎಮ್ಮಿಗೆ ಡಿರೈವ್ ಮಾಡಿಕೊಂಡು ಮತ್ತೆ ಹೋಗಬೇಕಷ್ಟೆ. ಅದನ್ನೇ ಇದ್ದಾಗ ಚೇಂಜ್ ಮಾಡಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಹಾಕಬೇಕು. ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಬೋದು. ಓಕೆ, put x equal to 2y, get a new formula, apply. Okay, that can be. Illi my reduction formula helps in reducing the index of sign. Why should we have any partiality over this sign function? Why not think of reducing this? That also can be done. ಸ್ವಲ್ಪ ಸ್ಲೈಟ್ ಚೇಂಜ್ ಮಾಡಿದ್ದರೆ ಮೆಥಡನ್ನು, I could have retained the index of sin unchanged, index of cos reduced by 2. ಹಾಗೂ ಮಾಡ್ಬೋದಿತ್ತು. You could have obtained the required integral in terms of integral sin power mx cos power n minus 2x. That also is possible. Only thing what you have to do is, instead of treating the integrand like this, you have to treat it as cos power n minus 1x into sin power m minus 1x into cos x. ಆ ರೀತಿ ಟ್ರೀಟ್ ಮಾಡಬೇಕಿತ್ತು. ಹಾಗೆ ಮಾಡಿ ಮುಂದುವರಿಸಿದ್ರೆ ಇನ್ನೊಂದು ರಿಡಕ್ಷನ್ ಫಾರ್ಮುಲಾ ಯು ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್. ಬೋತ್ ಆರ್ ಆಫ್ ದ ಸೇಮ್ ಟೈಪ್, ಬಟ್ ದೇ ಆರ್ ಡಿಫರೆಂಟ್ ಅಷ್ಟೇ. Okay, this is about reduction formula, use of reduction formula.